Welcome back to my channel JBR Online Classes. Like, share and subscribe my channel. Hello everyone, so in this video I am going to start from sum number 32. For the previous one, please check the description box, the link will be there. So here in sum number 32, you have to find out the multiplicative inverse of each of the following. So you know that the multiplicative inverse, if this one equal to z, then definitely the multiplicative inverse will be 1 by z. So as here 1 by z equal to 1 by 2 minus 3i. Now here you have to multiply this one with 2 plus 3i, that means the conjugate of this one. Okay, so now it will be here 2 plus 3i and the lower one will be a square minus b square formula. So 4 minus 9i square, as I square equal to minus 1, so 4 plus 9. So it will be 2 plus 3i by 13, then 2 by 13 plus 3 by 13i is your answer. Second one, that means here third one, second one is very easy, you can solve it. So here third one, z equal to 3 plus root 7i. Then 1 by z equal to 1 by this one. Now again you have to multiply this one with the conjugate. So 3 minus root 7i by 3 minus root 7i. Upper one 3 minus root 7i, lower one a square minus b square formula. So it will be 9 minus 7i square. I square means minus 1, that means 9 plus 7, so it's 16. Now separate it. Now next one, sum number 33. Express the following complex numbers in the form of a plus b. So as here the first one is 5 plus 9i by minus 3 plus 4i. Okay, so first you have to multiply with the conjugate of the denominator. So minus 3 minus 4i by minus 3 minus 4i. Then here the multiplication of these two complex number, you will get this one, and here a square minus b square formula. So it will be 9 plus 16, this one minus 15, and as this one 36 minus 36 I square means minus 1, so it will be plus 36, and this one minus 47i. So now 15 here plus 36, so 21 by 25, and then minus 47 by 25i is your answer. Second one, z equal to minus 1 plus root 3i to the power minus 1. Okay, now to the power minus 1, that means you can write down this one 1 by this one. Now multiply with the conjugate number, then upper one will be this one and lower one will be a square plus b square formula. So it will be 1 plus 3, so minus 1 by 4 minus root 3 by 4i is your answer. Now the third one, z equal to 2 plus 3i whole square by 2 plus i. So first you have to find out the whole square of this one. 4 plus 12i, that will be minus 9, because here I square means minus 1. So now you have to multiply with the conjugate of this one. So 2 minus i, 2 minus i. After multiplication you will get 2 plus 29i, and the lower one will be 4 plus 1, that will be 5. So 2 by 5 plus 29 by 5i is your answer. Now sum number 4. So here in sum number 4, here z equal to 1 by 2 plus 3i into 1 minus 2i. Okay. So that means here what we will have to do, here first you have to here multiply these two complex number. So 2 into 1 it becomes 2, then here plus 3i, here minus 4i, so it will be only I. Okay, and next one here 3 into 2 minus 6i square. So now it will be 1 by, as here 2 and I square means minus 1, so that means 6 plus 2, that equal to 8. So 8 minus I. So 1 by 8 minus I. Now you have to multiply with the conjugate, and that is 8 plus I up and down. So the upper one will be 8 plus I and the lower one will be 64. Here minus I square. Minus I square means plus 1. So now it will be 65. So that means 8 by 65 plus I by 65 as your answer. Next one, number 5. Number 5, you have z equal to 2 plus I, and in denominator you have 1 plus I into 1 minus 2i. So that means here first you have to multiply the denominator. So whenever you multiply it will be 1, here plus I, here minus 2i, so it will be minus I, and then here minus 2i square, that means plus 2. Okay, so it will be now 3 minus I, so 2 plus I and 3 minus I. Now you have to multiply with the conjugate, so 3 plus I and here also 3 plus I. Then the upper one will be 6 and here 3i plus 2i, it will be 5i, and then I square means minus 1. Here also 3 square, that means 9, minus I square means plus 1. Okay, so now it will be 6 minus 1, that equal to 5 plus 5i divided by 10. So if 5 will be common, 1 plus I by 2. Okay, so your answer will be 1 by 2 plus I by 2. Now the last one, sum number 6. In sum number 6, in the numerator you have 3 minus 2i into 2 plus 3i, and the denominator you have 1 plus 2i, then multiply with 2 minus I. So whenever you multiply the upper one, as here 3 minus 2i into 2 plus 3i, so it will be here 12 plus 5i, and in the numerator you will get 4 plus 3i. Okay, so now you have to multiply with this one, 4 minus 3i up and down. So the upper one will be here 63 minus 16i. Whenever you multiply this one with this one, you will get 63 minus 16i, and the lower one will be 25, because 4 square means 16 and 3 into 3i, that means 9i square, so it will be plus 9, so 65. So your answer will be 63 by 25 minus 16 by 25 iota is your answer. Okay, now next, sum number 34. Express the following complex number in the form of a plus ib, and also find the conjugate and the modulus of each number. So here sum number 34, there will be 4 sum, and I am going to solve the second one and the fourth one, because all are same type of problems. So here in the second one, 3 plus root minus 1, 2 minus root minus 1. So first you have to write down this one, 3 plus I, because the value of root minus 1, that equal to iota, and here 2 minus I. Now if you multiply this one by the conjugate, so you will get 3 plus I into 2 plus I, it becomes 6 plus 5I minus 1, because iota square equal to minus 1, and the lower one will be 4 plus 1, because a square minus b square formula. So the upper one will be 5 plus 5I and lower one will be 5. So here 1 plus I is the answer. Now if you find out the conjugate of this one, that means z bar, if this one equal to z, so z bar equal to 1 minus I, and you have to also find out the modulus. So it will be 1 square plus 1 square, and that equal to root 2 is your answer. Now for the next one, that means fourth one. In fourth one you have here z, let 3 plus 2i whole cube. Okay, you know the formula of a plus b whole cube formula. So first a cube, then it will be b cube. B cube means 2 to the power 8, 3, it's 8, and then 3ab, and then a plus b. Okay, so now it will be 27, and here 8 cube means minus I, so it will be minus 8i. That one is 3 into 9 to 18, so 18i into 3 plus 2i. Now 27 minus 8i, here 18 into 3, that means 54i, and that equal to 36i square. So 27, here 54 minus 8, it will be 46i, and 36i square means minus 36. So 27 minus 36, it will be minus 9 plus 46i. Now you have to find out z bar or the conjugate. It will be minus 9 minus 46i, and here mod z will be root over minus 9 whole square, and that one will be 46 whole square. So your answer will be 2197 in root over. Okay, root over 2197 is your answer. Now sum number 35(1). Express the square of this one in the form of x plus iy. So as here z equal to this one, and if you squaring both sides, so z square equal to I square by 1 plus I whole square. So I square means minus 1, and 1 plus I whole square means here 1 plus I square plus 2I. So upper one will be minus 1, and here the lower one, as here I square equal to minus 1, so 1 cancel out. In the lower one you have only 2I, that means minus 1 by 2I. Now if you multiply it with I into I, that means iota. So here upper one equal to I and lower one will be 2 iota square, that means minus 2. So minus minus cancel out, it will be I by 2. Now as you have to form this one into x plus iz, so here z equal to as 0 plus I by 2. Okay, x z equal to 0 plus I by 2 is your answer. Now the next one, here 35(2). In 35(2), show that root 7 plus root 3I divided by root 7 minus root 3I plus root 7 minus root 3I divided by root 7 plus root 3I, that is real. Okay, so now as here the LCM will be the multiplication of these two. So you can here apply the formula of a square minus b square, because this one is negative and this one is positive. So it's very easy. So a square minus b square. Okay, and the upper one will be the whole square of this one plus the whole square of this one. So first write down here the whole square of the first one and then the whole square of the second one. So here a square b square, that means 7 plus 3I square. Okay, 7 plus 3I square. Next one here also 7 plus 3I square, and here will be 2ab. So you have to write down 2 root 7 root 3I. Here also minus 2ab. So 2 root 7 root 3I, and these two will be cancel out. This one will be 7 minus, as here 3I square, I square means minus 1, so 3 plus 7. Okay, now the upper one, here 7 plus 7 14, as here 3I square plus 6I square. 6I square means minus 6, because I square equal to minus 1, it will be 10. So here 14, that means 8 by 10, and that equal to 4 by 3. So 4 by 3 is a real number. So that is, you can say that this one equal to 4 by 3 and it's a real. Okay, so it's proved. Now here sum number 35(3). Find the modulus of this one. So here first you have to no need to multiply these two complex number here. As you know, if you take mod in both sides, so here the left hand side will be mod and the right hand side will be mod of this one. Okay, so here also minus 3 plus 2 root 5. Now there will be a properties of mod. You know that if z1 by z2 in mod, so it will be mod z1 then by mod z2, and if z1 z2 multiplication form in mod, so it will be mod z1 then mod z2. Okay, so now as here if you consider the upper one as z1 and the lower one as z2, then you can here apply this one. So it will be the upper one will be within mod 1 plus 3i 2 minus 5i, and the lower one also within mod 2 minus root 6i minus 3 plus root 5i. Okay, so now here again you can apply these properties. Within mod, if this one equal to z1, this one equal to z2, so you have to first write down the mod of this one, and the mod of 1 plus 3i, it will be 1 square plus 3 square, and again the mod of second one, it will be 2 square minus 2 square plus here minus 5 whole square. Now the lower one, it will be also mod of this one, so 2 square plus here minus root 6 whole square, again root over minus 3 whole square plus 2 root 5 whole square. Okay, it's very easy. Now from the first one it will be mod 10, and from the second one will be 4 and here 5, so 25. 25 plus 4, that equal to 29. Now the lower one, here 2 square means 4 and root 6 whole square means 6, so 4 plus 6 it will be also 10, and the lower one, here 3 square means 9 and here 2 square means 4 into 5 20, so 29 means 29. Okay, So it's equal, so that means that equal to 1. So the modulus of this one equal to 1. Now sum number 36. Find if z equal to 2 minus I and z2 equal to minus 2 plus I, then find imaginary z1 z2 by here z1 bar, real 1 by z1 z1 bar, and imaginary 1 by z1 z1 bar. Okay, so as here z1 equal to 2 minus I, then definitely z1 bar equal to 2 plus I. Is it clear? And z2 bar that equal to minus 2 minus I. So first you have to find out z1 z2 by z1 bar. So write down here z1 z2 by z1 bar. So z1 z2 means here z1 equal to 2 minus I and z2 means minus 2 plus I, and z1 bar means 2 plus I. Okay, so now if you multiply, it will be minus 4, here minus 2I, and that will be plus 2I. Okay, minus 2I and plus 2I. So here minus 2, it will be here minus into minus, so it will be here plus 2I, then here again plus 2I, and the last one will be minus I square, and here the lower one will be 2 plus I. So the upper one will be here minus 4 plus 4I, and it will be minus I square, so it will be plus 1, then 2 plus I. So now it will be minus 3 plus 4I divided by 2 plus I. Okay, so minus 3 plus 4I. Now if you multiply with the conjugate one, here 2 plus I multiply with 2 minus I, then that one equal to here minus 6 plus 8I plus 3I and minus 4I square, and that one equal to 4 minus I square. So here minus 6 and that one equal to plus 4, so it's minus 2, and that equal to 11I, here it will be 5. So minus 2 by 5 plus 11 by 5I. Now you have to find out the imaginary part of z1 z2 by z1 bar, and that equal to 11 by 5. Okay, that equal to 11 by 5 is your answer. Now for the second part, here 1 by z1 into z1 bar. So what is the value of z1? You know that here the value of z1 equal to 2 minus iota, and value of z1 bar equal to 2 plus iota. So it will be 1 by, this one will be 4 minus I square, that means here 1 by 4 plus 1, that equal to 1 by 5. Okay, so now you have to find out the real part. So as here 1 by 5 is the real part, so 1 by 5 is your answer. Now the third one, you have to also find out the imaginary part. The imaginary part of 1 by z1 bar. As here this one equal to 1 by 5, so if you write down in this way, so here imaginary part will be 0. So 0 is your answer. Now sum number 37. Here x plus iy into 2 minus 3i, that equal to 4 plus I. So first you have to multiply here, it will be 2x plus 2iy, then minus 3xi, the last one will be here minus, as here I square, so it will be plus, and 3y, that equal to 4 plus I. So here the real part are 2x plus 3y, then if I will be common, so it becomes 2y minus 3x, and that equal to 4 plus I. So now if you compare it in both sides, then you will get here 2 plus 3y, that equal to 4, and the next one minus 3x plus 2y, that equal to 1. Okay, so now here if you multiply this one with 3, you will get 6x plus 9y, that equal to 12, and if you multiply this one with 2, you will get minus 6x plus 4y, that equal to 2. Now if you add these two equation, then 6x will be cancelled out, so 9y plus 4y, that equal to 13y, and here 12 plus 2, that equal to 14. So from that y equal to 14 by 13. Okay, and if y equal to 14 by 13, then just put down the value of y in the first equation. So that means here 2x equal to 4 minus 3 into 14 by 13, and from that you can easily find out the value of x, which is 5 by 13. Okay, now the next one, number 2. In number 2 you have x minus 2 plus y minus 3i that divided by 1 plus I, that equal to 1 minus 3i. So you can also write down this one, x minus 2 then y minus 3i that equal to 1 minus 3i multiply with 1 plus I. Okay, so here x minus 2 plus y minus 3i, and if you multiply this one you will get 1, and here minus 3i, here plus I, so it will be minus 2i, and the last one will be plus 3, so that one equal to 4 minus 2i. Okay, 4 minus 2i. Now if you compare it, so you will get here x minus 2 equal to 4, and from that x equal to 6, and next one y minus 3 that equal to minus 2, so y equal to 1 as your answer. Now the next one, number 4. In number 4 you have 1 plus I x minus 2y by 3 plus I plus 2 minus 3i into y plus I by 3 minus I, that one equal to I. Okay, now this one is in your 2021 edition book. Okay, it will be not in your 2020 edition book. So you have the 2020 edition book, then there will be only 3 sums, but in 2021 edition book there will be the 4th one. So as here 3 plus I and 3 minus I, so the LCM will be 9 minus I square, and you know that first you have to multiply x with this one and then multiply 3 minus I with this one and 3 plus I with this one. So now multiply 3 into x, then 3 into xi, 3 into minus 2 6i, then multiply I, so minus xi, as here xi into minus I, so it will be minus xi square, and that's why written here as minus x, plus x, because I square equal to minus 1, you know that. Now next one here minus 2i into minus I square, so it will be minus 2, as same as you have to multiply this one. So now you will get 3x, and here x 4x, 6y plus 3y that equal to 9y, then here 3xi minus xi 2xi, and here 9yi and plus 2y, it's minus 7y, and that one equal to minus 3i minus 3 that equal to 10i, because here 9 minus I square that equal to 10, 10 into I, it will be 10i. Now 4x plus 9y plus, here if I will be common, 2x minus 7y and 3 will be in the right hand side, so plus 3, and then 10i plus 13i, 10i plus 3i that equal to 13i. Now if you compare the both side, then you will get here 4x plus 9y that equal to 3, and here 2x minus 7y that equal to here 13. Now if you multiply 2 with this equation, you will get 4x minus 14y that equal to 26. Now if you subtract this one from this one, and you will get here minus 23y that equal to 23. So from that y equal to minus 1, because here x will be eliminated, and then just put down the value of y in this equation, and then you will get x equal to here 12 by 4, and that equal to 3. So x equal to 3 and y equal to minus 1 is your answer. Now sum number 38. In sum number 38, if this one equal to this one, then you have to prove that the first one, you have to prove that here a minus ib by c minus id that equal to p minus iq. So it's very easy. You have to first take conjugate in both sides. So if you take conjugate in both sides, then the upper one will be a minus ib and the lower one will be c minus id, and here also the conjugate of this one, p minus iq. Okay, and it's proved. So that will be the first one. Now the second one. In the second one, you have to prove that p square plus q square equal to a square plus b square plus c square plus d square. Okay, so that means here first you have to take mod in both sides. So that one will be a plus ib, c plus id within mod, and here also p plus iq within mod. You know that mod z1 by z2, it will be mod z1 in the upper one and mod z2 in the lower one. So the mod of this one equal to a square plus b square, mod of this square that equal to c square plus d square, and this one will be root over p square plus q square. Now if you square both sides, then you will get a square plus b square, here c square plus d square, that equal to p square plus q square. You have to just write down here formula mod z1 by z2, that equal to mod z1 by mod z2. Okay, now sum number 39. Here x plus iy equal to root over 1 plus I 1 minus I. So first here you have to multiply this one with 1 plus I in upper one and also in the lower one. So lower one will be a square minus b square formula, and the upper one as the whole square of 1 plus iy as here root, so it will be only 1 plus I, and the lower one as here 1 square, here I square, so 1 plus 1 it's 2, so it will be root 2. Okay, that means x plus iy equal to this one. Now if you take mod in both sides, then you will get this one 1 plus I, here root 2. Okay, so now the left hand side, the mod of this one is x square plus y square, and here 1 by root 2 here, and the mod of this one equal to 1 square plus 1 square, so that becomes 1 by root 2 into 1 by root 2, and that equal extremely sorry, it will be root 2 in upper one, because here root over 1 square plus 1 square, that equal to only root 2, not 1 by root 2. So now root 2 cancel out, so it will be 1. So that means here root over x square plus y square, and that equal to 1. It's proved. Now sum number 40, and this is the last sum for this video. So guys, if you like my video, please share this video and please subscribe my channel. So here a plus ib equal to x plus I whole square by 2x square plus 1, and you have to prove that this one. So as here a square plus b square, that means definitely you have to find out the mod of this one. So taking mod in both sides, so it will be mod a plus ib, and the upper one will be mod x plus its whole square, and lower one will be 2x square plus 1. Okay, so here as 2x square plus 1 is a normal number, so you don't need to take here mod. Okay, so it will be just write down 2x square plus 1. So now the mod of this one, okay, the mod of this one, that equal to root over a square plus b square, and you know that here mod z square, that equal to mod z square. Okay, so now it will be, you can write down mod x plus I square, and the lower one will be 2x square plus 1. Okay, so here root over x square plus b square, and this one will be root over x square plus here 1 square and the whole square, and that one equal to 2x square plus 1. So left hand side you have a square plus b square, right hand side in the topper you have x square plus 1, and in denominator you have 2x square plus 1. Okay, now if you squaring both sides, then you will get a square plus b square, that equal to x square plus 1 whole square, and here 2x square plus 1 whole square, and it's proved.